All right, hello everyone. My name is Brian, and I'm happy to be here today to tell you a bit about AI Jukebox, which is an exploration in generative neural network models. So I'd like to start out with a quote today by the legendary theoretical physicist Richard Feynman. "What I cannot create, I do not understand." So to take a bit of liberty with the interpretation of this quote, I'd just like to kind of draw out an implied symbiotic relationship between creation and understanding. So this model is actually going to develop a machine understanding by mapping the internal relationships of its data set in order to generate new and unique content. So again, the model takes in, as a generative model, it takes in a data set such as a collection of MIDI files. It maps the internal latent structure to gain a machine understanding, and then it outputs unique created content. So there are many potential applications of generative models, including images, audio, and text, with potential for many more. So the underline of this model is an LSTM network. Again, that stands for long short-term memory. And the real benefit of this type of model is the fact that it has both long and short-term memory, hence the name. So in order to, it is able to maintain both types of memory through managing a cell state through several gate layers within each node. Okay. So the tools that were used in this model are Keras with TensorFlow as the backend for the neural network, and Music21 and MuseScore for the music analysis. The architecture of the model is a bidirectional LSTM. So what that means is that there are actually two LSTM layers. So one is trained on the sequence of notes and chords in the forward direction, and the other layer is trained on the same sequence in the reverse direction. So there are also two dense layers in the network, and dropout is used throughout. And as mentioned, the data set is a collection of MIDI files, which are separated by genre. So this model generates new music by, the process is within the underlying data set, starts at a random location, and then looks at a window of notes. And then utilizing a probability distribution, it then predicts, so say we have a window of 200 notes. So it predicts the 201st note, then it shifts over one and predicts the 202nd. And it keeps doing that until it has generated all of the notes that we requested, in this case 500. So I'm about to play a demo of what the AI Jukebox has created. So just a couple things to keep in mind. So this model is generative in that there is no discriminator other than us. So what do we think about to discriminate? Well, in this case, just try and hear kind of recurring patterns and maybe a bit kind of melodic, etc. And most importantly, make sure it's kind of pleasing to the ear. Okay, so that was just a real quick snapshot of what it can do. So this was trained on a Celtic music data set in piano. So key takeaways from this project are that we explored one way a model can generate new and unique content. Hopefully you'll agree there were kind of some interesting, perhaps evocative rhythmic patterns in that short demo, but perhaps not in the running for awards just yet. The model just scratches the surface in terms of generative modeling, particularly in music. There's plenty more work to be done. And speaking of other work to be done, there's several tweaks that we can do to continue to refine the performance of this model. We can look into different data sets. So I looked into a few different genres. We can perhaps narrow that further into specific artists or style of artist. We can look into different architectures, such as generative adversarial networks, or GAN, variational autoencoders, and attention RNN, all of which have gained significant traction in the music generation area. And finally, we can look into different inputs, such as raw audio and text. And finally, I would love to put this into a web app where a user would just input a collection of music files, and unique AI-generated content would be output. And with that, thank you, and happy to answer any questions. Any questions?
Yeah, you were talking about feeding in content and then getting a generated musical output. So, like, how many songs would you have to input like for that stuff to be done?
Well, really, the more the better. I got better results when I had a few hundred MIDI files in my data set. And also, it takes a long time to train. I typically used about 200 epics.
So just to clarify, the music you fed in was Celtic music that's only piano playing?
Well, it's MIDI files, so it's actually, you have to synthesize it in order to kind of add the instrument, but it's the notes. Yeah, so it was training on the notes and chords.
So for something like MIDI, it's like a piano roll, right? So you're basically just talking about one relationship of a note to the previous one?
Yes.
Were you looking at duration? Were you looking at polyphony? How many notes at the same time? There's so many different dimensions.
It can be any note at the same time. Basically, within the data set, it will break out every unique note and chord combination and put that into a softmax. And then based on a probability distribution of all of those, which is kind of based on a sequence window. So the window, so say kind of randomly within the data set, looks at 200 notes and predicts the 201st. This model is kind of an early stage model. You use a single musical instrument. It's all eighth notes. So there's more work to be done. Yeah.
Great.